you guys know that JEE is nearing, right? आप लोग का जो एग्जाम है अप्रैल सेशन का JEE वो आने वाला है. So in every video, in every session, we take up some chapters from the syllabus of JEE and we discuss the concepts of those chapters with the help of some very important questions, right? Biomolecules, polymers and chemistry in everyday life. Okay, please remember that coupling will occur only with diazonium cation, and diazonium cation is formed by only primary aromatic amine, right? The number of stereocenters present in linear and cyclic structures of glucose. This question has been asked many times. You guys know that biomolecules, polymers and chemistry in everyday life. There are questions in JEE, right? You can expect 3 to 4 questions, generally 3 questions from these 3 chapters. Again, a very important, reaction. You study this in surface chemistry also and biomolecules also, because enzymes are biomolecules. So this question is selected because JEE asks, what do they give you? A structure of polymer, and they ask you to figure out what will be the monomers or vice versa, right? Hello guys, welcome to this video. Welcome to this Power Up series where we discuss the important concepts with some examples. Now you guys know that JEE is nearing, right? आप लोग का जो एग्जाम है अप्रैल सेशन का JEE वो आने वाला है, तो इसीलिए आपके प्रिपरेशन में हेल्प करने के हम लोगों ने पावर अप सीरीज स्टार्ट की है, जिसमें हम लोग एवरी वीडियो में कुछ चैप्टर्स चूज करते हैं. ठीक है, जैसे इफ़ यू हैव नॉट वॉच्ड तो प्लीज़ यू कैन फाइंड द वीडियोज़ ऑन आवर यूट्यूब चैनल. हम लोगों ने फिजिकल केमिस्ट्री 3 सेशंस में कवर की है और आज हमारा ऑर्गेनिक केमिस्ट्री का सेशन 3 है. ठीक है, सो इन एवरी वीडियो, इन एवरी सेशन we take up some chapters from the syllabus of JEE and we discuss the concepts of those chapters with the help of some very important questions, right? तो आज के सेशन में हम लोग ऑर्गेनिक केमिस्ट्री वाइंड अप करेंगे. ठीक है, लेट मी टेल यू, टुमारो ऑनवर्ड्स वी विल स्टार्ट विद इनऑर्गेनिक केमिस्ट्री एंड यू गाइस नो इनऑर्गेनिक केमिस्ट्री में कुछ बहुत ही इंपॉर्टेंट चैप्टर्स है, जैसे केमिकल बॉन्डिंग, कोऑर्डिनेशन केमिस्ट्री, लाइक दैट. ओके, राइट? तो ज़रूर सब्सक्राइब करो यूट्यूब चैनल को, ताकि तुम्हें पता चले कि हाँ, हम यहाँ पर इतना हेल्पफुल कंटेंट जो तुम लोगों के लिए बना रहे हैं, राइट? तो आज के जो चैप्टर्स हैं हमारे वो है अमीन्स. हम लोगों ने 2 सेशंस ऑलरेडी कर लिए हैं ऑर्गेनिक केमिस्ट्री के, जिसमें हमने जीओसी हाइड्रोकार्बन्स और क्लास 12th के दूसरी वीडियो में हेलोएल्किन्स, अल्कोहल्स और एल्डिहाइड्स डिस्कस किया. ठीक है, तो आज हमारा ऑर्गेनिक केमिस्ट्री का 3rd सेशन है. टुडे इज आवर 3rd सेशन वेयर वी विल डिस्कस इंपॉर्टेंट कॉन्सेप्ट्स, इंपॉर्टेंट क्वेश्चंस फ्रॉम द चैप्टर अमीन्स, बायोमोलिक्यूल्स, polymers and chemistry in everyday life. Okay, so without much delay, let's get started with the first question. Question is here on your screen. Pause the video, solve the question yourself and then check the answer. और अगर तुम्हें revise करना है, if you guys have come here to revise the concept, then you should watch the video. All right. The final major product of the following reaction. यहाँ पर बताना है कि product क्या होगा major product. ठीक है, तो ध्यान से देखो यहाँ पर हमें क्या करना है. ये हमारा कंपाउंड है, बेंजीन रिंग है, मिथाइल सब्स्टिट्यूएंट है और ये हमारा NH2 ग्रुप है, राइट? तो सबसे पहले हमें किससे रिएक्शन करानी है? एसिटिक एनहाइड्राइड से. गाइस, AC जो है इट इज सिंबल फॉर एसिटाइल ग्रुप. लेट मी टेल यू, राइट? जो AC है ये इस ग्रुप का सिंबल होता है, एसिटाइल ग्रुप, राइट? तो AC ट्वाइस हो मतलब ये एसिटिक एनहाइड्राइड की बात कर रहा है, AC2 मतलब ये एसिटिक एनहाइड्राइड की बात कर रहा है. पिरिडीन हमारा बेस है प्रोटॉन हटाने के लिए. तो प्लीज रिमेंबर, जब भी तुम किसी एसिटिक एनहाइड्राइड हुआ, एसिड एनहाइड्राइड हुआ या फिर एसिड क्लोराइड हुआ, ठीक है, उसकी रिएक्शन तुम किसी भी फिनॉल या एनिलीन किसी से करा रहे हो जो स्ट्रॉन्ग न्यूक्लियोफाइल की तरह एक्ट कर सकता है, then this reaction is nucleophilic acyl substitution, and what will happen here is that after the reaction of this aniline derivative with acid anhydride, what will happen? This group will come here, right? Basically what happens that it attacks here, right? This nitrogen attacks here, this pi bond breaks, the remaining group leaves and also one of the hydrogen leaves. So basically यहाँ पे क्या होगा? What will happen here? So methyl will remain as it is, nothing will happen to it, but in this case this will undergo acetylation. All right, this will undergo acetylation. Is that clear? Okay, so AC2O pyridine, please remember, whenever you react any aniline or any amine for that matter, you get substituted amide, right? In this case you will get this NHCOCH3. basically a hydrogen on nitrogen will be substituted by the acetyl group. Okay, now what is the effect? NH2 is a very strongly activating group, right? Because it has lone pair and nitrogen is not so electronegative. but here the lone pair is not very much available because it is involved in resonance with the carbonyl group. That means as compared to NH2, this NHCOCH3 group is moderately activating group. So what happens, अब जब तुम इसका reaction कराओगे, ठीक है, if this molecule undergoes this electrophilic substitution reaction, what happens? Bromine will provide the electrophile and FeCl3 is your Lewis acid catalyst. So what will happen here, guys? Can you tell me what are the positions for substitution here? क्या आप लोग मुझे बता सकते हैं कौन कौन सी पोजीशन पे सब्सटीट्यूशन यहाँ पे हो सकता है? देखो, एक तो इस पोजीशन पे हो सकता है ऑर्थो, राइट, एक इस पोजीशन पे हो सकता है ऑर्थो, और एक इस पोजीशन पे हो सकता है पैरा. Now you guys can see that this is a bulky group. NHCOCH3 is a huge bulky group. So substitution at this position will be highly unfavorable because of steric hindrance, and also at this position, right? So the least unfavorable position, or we can say the most favorable position, is this para position. Okay, तो हमारा यहाँ पे प्रोडक्ट क्या बनेगा आफ्टर द रिएक्शन विद ब्रोमीन इन FeCl3? हमारे यहाँ पे प्रोडक्ट क्या बनेगा गाइज? सिंपल, विद रिस्पेक्ट टू NHCOCH3 जो एक ब्रोमीन है वो आके सब्सटीट्यूट हो जाएगा. ठीक है, यहाँ पे हमारा ये ब्रोमीन आ जाएगा और ये क्या बन जाएगा? NHCOCH3. नाउ नेक्स्ट स्टेप आप लोगों को पता है क्या होगा? नेक्स्ट स्टेप में हम OH माइनस हीट कर रहे हैं, मतलब एल्कलाइन हाइड्रोलिसिस कर रहे हैं. तो ऑलवेज रिमेंबर, whenever you have any carboxylic acid derivative, right, ester, acid chloride, amide, anhydride, anything, nitrile, if you hydrolyze it under acidic or alkaline condition, it will give you what? Carboxylic acid will separate and this bond will break, right? तो basically ये वापस convert हो जाएगा NH2 में और this will separate as CH3 CO माइनस, क्योंकि मीडियम अल्कलाइन है, वरना हमारा एसिडिक एसिड बनता. तो ये हमारा मॉलिक्यूल जो है वो इसमें बन जाएगा. अब देख लो इसमें करेक्ट आंसर कौन सा है हमारा? ये बेंजीन, MEBr एंड NH2. तो गाइस ऑप्शन डी हमारा इसमें करेक्ट आंसर हो गया. ओके, सो वेरी गुड. यहाँ पे हमने इतनी सारी चीजें देखी, एसिटाइलेशन, देन इलेक्ट्रोफिलिक सब्स्टिट्यूशन, बेसिकली ब्रोमिनेशन, एंड देन आफ्टर दैट हाइड्रोलिसिस. ओके, मूविंग टू द नेक्स्ट क्वेश्चन. Which of the following amines can be prepared by Gabriel Thalamide? Please remember that in amines there are few reactions which are asked repetitively, right? Every year. So these are Hoffman bromamide degradation, you know that, Gabriel Thalamide synthesis, carbylamine reaction, like that. Okay, so कौन सा अमीन हम बना सकते हैं गैब्रियल थैलिमाइड सिंथेसिस से? तो प्लीज याद रखना, गैब्रियल थैलिमाइड सिंथेसिस जो है वो SN2 मैकेनिज्म फॉलो करेगा जनरली. इसका मतलब दैट मीन्स you have to take primary and unhindered alkyl halides, right? That you can take, primary it should be, and unhindered मतलब अगर तुम्हारे alkyl halide पे haloalkene if there is a steric hindrance, तो please remember whenever there is a steric hindrance, elimination dominates over substitution, right? Substitution is not favored by steric hindrance. Okay, so primary unhindered alkyl halide, right? And of course it will give you primary unhindered amine on Gabriel Thalamide synthesis, right? So very simple guys, try to draw these amines structures and then find out कि उनमें से कौन सा हम Gabriel Thalamide synthesis से बना सकते हैं. चलो स्ट्रक्चर बना के देखते हैं. So this is CH3, CH2, 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 NH2. Yes, ये तो बन सकता है, राइट? गैब्रियल थैलिमाइड सिंथेसिस ये बन सकता है. कैसे बन सकता है? वेरी सिंपल. इसमें हम क्या लेंगे? लेट मी टेल यू. राइट, ये वाला न्यूक्लियोफाइल ले लेंगे. थैलिमाइड की रिएक्शन आप कराएंगे NaOH KOH से. सो एसिडिक हाइड्रोजन विल गो अवे. दिस इज आवर न्यूक्लियोफाइल, स्ट्रॉन्ग न्यूक्लियोफाइल, एंड देन इट विल अटैक दिस. यू कैन टेक फॉर एग्जांपल N-ब्यूटाइल ब्रोमाइड, ये ले सकते हैं. वी कैन टेक दिस. Please understand these concepts very carefully, right? This bromide will leave. Okay. Now the resulting intermediate can be hydrolyzed, generally in alkaline medium, and then you will get. So I'll show you what is the intermediate as well. Intermediate क्या हम वो भी देख लेते हैं. So Gabriel Thalamide is a very important reaction, guys. Don't leave this reaction. CH2, 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 CH3. Okay. Now you will hydrolyze this compound, so you will get N-butylamine. So that will be the correct answer in this question. Now of course triethylamine is a tertiary amine, we can't prepare it, right? Triethylamine is this, ethylamine is this, CH2CH3, CH2CH3, CH2C. We can't prepare, right? Tertiary butylamine is this. It is primary amine, but you can see it's a lot of steric hindrance, right? It's a lot of steric hindrance. You will have to use a tertiary alkyl halide which will not react by SN2 mechanism. And neopentylamine, it is primary, but again it has steric hindrance, right? Neopentyl group kaun sa hota hai guys? Which group is neopentyl? This is neopentyl, right? So this is neopentyl. If you put like NH2 here, this becomes neopentylamine. No, we cannot prepare, although it is primary, but it has a steric hindrance. So Gabriel thalamide synthesis is a very, very important reaction. Moving to the next question. एक क्वेश्चन मुझे लेना था, हॉफमैन ब्रोमामाइड एंड कार्बाइलमीन. These two are very, very important reaction. Please revise and do some questions on them. हॉफमैन ब्रोमामाइड डिग्रेडेशन एंड कार्बाइलमीन रिएक्शन. ध्यान से पढ़ो इस क्वेश्चन को कैसे करेंगे. A compound acts on treatment with bromine NaOH, right? So this is the reagent that we use in Hofmann bromamide degradation reaction. Provided C3H9N, it's an amine definitely, right? Then which gives positive carbylamine test. So what is carbylamine test? Please remember that it is given by primary amines that can be aliphatic or aromatic. Aromatic as in you can take aniline. Aniline will also respond to carbylamine test, right? Or you can take aliphatic amine, for example ethylamine, like that. Then when you react it with chloroform and KOH, then you guys know what happens. This is the reagent of carbylamine reaction. What happens? This will give you pungent smelling isocyanides, right? This will give you pungent smelling isocyanides. So that reaction is called positive carbylamine test, okay? Right? Now अब इसमें से देखो, bromine and NaOH है, Hofmann bromamide degradation. What happens in Hofmann bromamide degradation? I'll tell you. Again, यहाँ पे you have to take primary amides as in unsubstituted amides, ठीक है? यहाँ पे unsubstituted amides लेने हैं, वो aliphatic हो सकता है, aromatic हो सकता है. That means you can either take CH3CONH2 or you can take this benzamide, benzene CONH2. Both will respond to this Hofmann bromamide degradation reaction. तो जैसे हमने ये लिया, अब इसकी रिएक्शन हम लोग कराएंगे ब्रोमीन और NaOH से. क्या हो जाएगा यहाँ पे? बड़ा सिंपल सा ट्रिक है गाइस. मैकेनिज्म बहुत लंबा है हॉफमैन ब्रोमामाइड का, बट सिंपल सा ट्रिक है, बीच में से CO हटा देना, राइट? तो व्हाट यू विल गेट दिस RNH2. इसका मतलब दैट मीन्स फॉर अ कंपाउंड to be able to react in Hofmann bromamide degradation reaction, it must be like RCONH2. So this will not react, this will not react, this will not react. The only choice left is this one, right? Because this is not RCONH2, this is not, this is not. एक बार चेक कर लेते हैं फाइनली. तो CH3 CH2 CH2 C double bond O NH2, right? CH3 CH2 CH2 C double bond O NH2. तो जब तुम इसकी रिएक्शन करोगे ब्रोमीन एंड NaOH से, Hofmann bromamide degradation reaction होगी गाइस. तो what will happen? This carbonyl group will go away and you will get CH3 CH2 CH2 NH2. Yes, okay. So the formula matches C3H9N. Okay. Then does it give positive carbylamine reaction? Yes. If you reacted with chloroform and KOH, then yes, because it's a primary amine, so it will respond to the carbylamine reaction. और यहाँ पे हमारा क्या बन जाएगा? We will get this. Okay, right? We will get this CH3 CH2 CH2 and then this will be NC. Okay, right? तो this will be the product. Yes, that is the correct answer. इसमें बताओ क्या होगा? Basic strength में भी question आता है, means कि that is why I have taken 2 questions from basic strength, because basic strength is very important in this chapter. Considering the basic strength of amines in aqueous solution, which one has the smallest pKb value? तो उसने बता दिया गाइज, यहाँ पे aqueous solution की बात कर रहे हैं, वो हमें वैसे ही पता चल जाता. pKb की बात हम generally aqueous solution में बात करते हैं, right? Now do you guys remember that basic strength जो है, right? किसी भी बेस की जो बेसिक स्ट्रेंथ है वो Kb पे डायरेक्टली डिपेंड करती है और pKb पे इनवर्सली डिपेंड करती है. द रीजन इज सिंपल, बिकॉज pKb is minus log Kb, right? तो greater the value of base dissociation constant, obviously stronger the base, and because of minus sign pKb varies inversely with the basic strength. इसका मतलब क्वेश्चन में पूछ रहा है which has the smallest pKb. pKb is the smallest, that means basic strength is maximum. तो सिंपली दे आर आस्किंग विच इज द स्ट्रॉन्गेस्ट बेस, बस इतना पूछ रहेगा इस क्वेश्चन में, विच इज द स्ट्रॉन्गेस्ट बेस इन वाटर, which is the strongest base in water. Now you should remember that aliphatic amines are more basic than aromatic amines. तो aniline कम basic हो जाएगा because the lone pair on nitrogen in aniline it is involved in resonance, so it is not that much available for donation. So please remember that aliphatic amines are stronger bases. Aliphatic amines are stronger bases as compared to aromatic amines. So this cannot be the answer. Now out of these, please remember secondary amines are always most basic, right? Secondary amines are always most basic because they have a moderate amount of plus I effect, they have hydrogen bonding also, and in them steric hindrance is also not very much. ठीक है, तो irrespective of the alkyl group, please remember secondary amine will be the most basic in aqueous medium, right? In gas phase tertiary amine will be the most basic. Okay, so यहाँ पे हमारा correct answer कौन सा हो जाएगा, ये वाला हो जाएगा. Next question, aniline dissolved in dilute HCl is reacted with sodium nitrate at 0 degree Celsius, right? This solution was added dropwise to a solution containing equimolar mixture of aniline and phenol in dilute HCl. There lies the trick of the question, right? तो aniline हम लोग जानते हैं, अगर तुम उसकी reaction कराओगे guys, if you react, right, aniline with dilute HCl and sodium nitrite हो गया और dilute HCl, together they react and they form HNO2 in situ, right? In situ मतलब within the reaction mixture. So when you react a primary aromatic amine with sodium nitrite and HCl, they form nitrous acid, then it undergoes diazotization, right? To cut the long story short, basically यहाँ पे क्या बनेगा, N2 plus and Cl minus, बेंजीन डाइजोनियम क्लोराइड बन जाएगा, बेंजीन डाइजोनियम सॉल्ट बन जाएगा. नाउ वी नो दैट बेंजीन डाइजोनियम cations they undergo coupling with those benzene rings which have very powerful activating groups like OH, NH2, in other words phenol and aniline. Now please remember, with phenol the coupling occurs in alkaline medium and with aniline the coupling occurs in a slightly acidic medium. It's the opposite, right? Because phenol ionizes in alkaline medium, so phenol is acidic compound, so phenol will be more reactive in alkaline medium, coupling will occur in alkaline medium. Aniline is slightly basic compound, so with aniline coupling will occur in slightly acidic medium. Okay, right? So aniline की हमने reaction कराई, diazotization कराया, ये diazotization हो गया, right? If you now do the reaction of this molecule with aniline, normal coupling will occur, with phenol normal coupling will occur, but they have made this question slightly tricky. That is, the solution was added dropwise to an equimolar mixture of aniline and phenol. Both are present, aniline as well as phenol, but in dilute HCl. So in acidic medium, phenol will not ionize, common ion effect, so phenol will not couple, aniline will couple. Okay, and always remember that coupling occurs at para position, right? Because this group is very huge. So what will be the correct answer? This one, right? Had the medium been alkaline, for example, dilute NaOH, then we would have written OH here instead of NH2. That means in slightly alkaline medium, phenol would have coupled, but in slightly acidic medium, aniline will couple, and this will be the correct answer. Okay, so very good question. It explains diazotization and the coupling concept. Next question. इस क्वेश्चन में क्या बोलोगे? 3 टेस्ट्स हैं इसमें, दैट इज वाई दिस रिएक्शन एंड ऑल द 3 आर इंपॉर्टेंट, वेरी फेमस नेम टेस्ट, नेम रिएक्शन. द टेस्ट परफॉर्म्ड ऑन कंपाउंड X and their inferences are given, right? So one of these is compound X and which responds to these 3 tests in these manner. So you have to tell what is the likely structure of that compound. It gives 2,4-DNP test, guys. Do you remember DNP test कौन देता है? सब लोग को पता है DNP test कौन देता है? Aldehydes and ketones देते हैं, है ना? Aldehydes and ketones 2,4-DNP, 2,4-dinitrophenyl hydrazine से react करके, depending upon the structure of the aldehyde or ketone, it could be orange, red or yellow PPT, right? Please remember that aldehydes and ketones, they react with 2,4-DNP derivative, 2,4-dinitrophenyl hydrazine, right? And depending upon the structure of the carbonyl compound, they give orange, red, yellow PPT. Okay, So it responds to the 2,4-DNP test. That means it has to be an aldehyde or a ketone. So this is not an aldehyde, right? So this cannot be the answer. Let us check other options because we did not know much. So from this iodoform test दे रहा है guys. Do you guys know iodoform test कौन देता है? Let me tell you, iodoform test वो देते हैं जिनमें या तो ये वाला functionality होता है, right? Either ये वाला group होता है, these compounds give iodoform test, or these compounds give iodoform test, right? The one which have methyl ketone or this methyl alcohol type CHOH, CH3. Is that clear? So these kinds of compound give iodoform test. It gives yellow precipitate, so it has to have this. So this cannot be the answer because it does not have, and this cannot be the answer, right? So either this cannot be the answer. So now we have this correct answer here. But let me tell you the third, azodite test. Azodite test is, guys, this only, that you are given a compound, right? You reacted with the diazonium cation. If it couples, then it gives azodite test. So basically what happens, please remember that coupling will occur only with diazonium cation, and diazonium cation is formed by only primary aromatic amine, right? Primary, because if you take aliphatic amine, they automatically decompose to alcohol. What I am saying is, if you take this CH3CNH2, it is also primary amine, but it is aliphatic, right? It is also primary amine, but it is aliphatic. So what will happen if you carry out the diazotization by reaction with NaNO2 and HCl? Then what will happen? This will be CH3, CH2 and N2 plus. Diazonium cation will form, but it is so unstable, right? So it will automatically decompose and will give you alcohol, right? But aromatic diazonium cation, they are resonance stabilized. So what will happen? They will react, but it has to be a primary amine, and you can see that it is a tertiary amine. You can see, right? It is joined to 3 carbon. It's a tertiary amine. It will not form di in azodite test. If you reacted with the diazotizing mixture, sodium nitrate and HCl, it will not form diazonium cation. It will not form di. So yes, this is the correct answer. 2,4-DNP test, yes, because it is a ketone, and iodoform test, yes, it will give because it has this functionality, COCH3, because it has C double bond O CH3, this functionality. Is that clear? Is that clear to everyone, right? Then this, right? Arrange the following amines in decreasing order of basicity. So these are nitrogen atoms basically, guys. These are nitrogen atoms. You have to tell what is the order of basic strength. There is nitrogen here, there is one nitrogen here, and there is one nitrogen here. So what do you think is the order of basic strength? Consider the factors. See, basically, basic strength, how do you determine basic strength? Either you can determine by the stability of conjugate base, if you can see that very easily, right? Stability of conjugate base. So this factor is generally sufficient. You can see stability of conjugate base, but also there is another factor, electron density, right? Because when we say basic strength, we mean Lewis bases, the one which can donate electron pair here in organic chemistry, right? So electron density means greater the electron density on the donor atom, greater will be the Lewis basic strength, greater will be the basic strength, right? So now tell me in which case the electron pair is most available, right? Can be most readily donated. So you will see that here it's an aliphatic amine, right? The lone pair of nitrogen, it is there. It is not involved in any kind of delocalization. The hybridization of nitrogen is sp3 also, which means least electronegative, right? 25% s character only. So third has to be the most basic. Now what is the story in first and second? You can see that second compound, if you don't know, then let me tell you, this is pyrrole, right? And it is aromatic because the lone pair on nitrogen, it is involved in resonance with the other two pi electron pairs, right? So this heterocyclic compound, it has one pi electron pair here, one pi electron pair here, and one electron pair on nitrogen. Together they form the Huckel sextet, right? Together they form the Huckel sextet. That means all these 6 electrons are involved in resonance. So if nitrogen donates its electron pair, it will become non-aromatic, right? That it will not want to do because aromatic compounds are highly stable. So second has to be least basic. That is, the availability of electron pair is minimum, right? So secondary is least basic and third is most basic. So of course first comes in between. Now what is the story with first? So answer you have gotten, I think third, first and second. Yes, third and then first and then second. Now what is the story with first? It is pyridine, right? It is pyridine. Electron pair is available. It is not involved in resonance, right? Because we have the 3 pi electron pair necessary for aromaticity. But the electronegativity of nitrogen is more. Why? Because here the hybridization of nitrogen is sp2. Right, here the hybridization of nitrogen is sp2. S character has increased from 25% to 33%. S character is more, nitrogen has become more electronegative. It is not comfortable with positive charge, right? So that is why pyridine is less basic than this. Okay, is that clear? So that is the correct answer here. Now let us discuss some questions from this. The number of stereocenters present in linear and cyclic structures of glucose. This question has been asked many times, and to answer this question you should know the structure of glucose, right? So glucose is, I think, the most abundant organic compound, if I am not wrong, right? So H, OH, OH, H in living beings, right? Then H, OH, and then H, OH, CH2OH, right? So this is the Fischer projection, right? The structure of glucose. So you can see that it is a carbohydrate, it's an aldohexose, it is an aldehyde functional group, it has 6 carbon atoms, it has 5 hydroxyl groups, 1, 2, 3, 4, 5, and this is a structure. So you can see that how many chiral carbons are here, guys? Can you locate here? Can you locate how many chiral carbons? This is a chiral carbon, this is a chiral carbon, this is a chiral carbon, this is a chiral carbon. So there are 4 chiral carbon in the open chain structure. Right, so number of stereocenter, right, asymmetric carbon, chiral carbon, simply sp3 hybridized carbon which is joined to 4 different groups, right? So in Fischer projection it's easy to figure out these intersection points, they indicate chiral carbons, right? Okay, so there are 4 chiral carbon in the open chain structure of glucose. Now what about cyclic structure of glucose? We know, guys, if you don't remember, please learn it. Okay, the open chain structure of glucose is not very stable, therefore it undergoes hemiacetal formation, right? That is a reaction of aldehyde and alcohol which we discussed in the last video. Please go there and watch it. So basically hemiacetal, right, hemiacetal structure, it forms cyclic structure, which I think, yes, so it is here. So that is the hemiacetal cyclic structure. Now if you see how many chiral carbons are there, right? This is 1 chiral carbon, 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 and this is 1 chiral carbon. So 1, 2, 3, 4, 5, there are 5 chiral carbons now. Okay, so what is the correct answer? 4 and 5, that is the correct answer in this question. Moving to the next. So these questions I have selected very carefully from biomolecules because to give I want to give an idea of how you should prepare these chapters which are significantly theoretical, right? You guys know that biomolecules, polymers and chemistry in everyday life, there are questions in JEE, right? You can expect 3 to 4 questions, generally 3 questions from these 3 chapters. So you should have an idea how should you prepare. Generally NCERT is sufficient, right? Here, so which of the following statement is not true about sucrose? It is also named as invert sugar. Correct or not, guys? Tell me quickly. It is also named as invert sugar. Yes. Why? Because sucrose is dextrorotatory. Sucrose is a dextrorotatory compound. On hydrolysis, it produces glucose which is dextrorotatory, and fructose which is levorotatory, right? Now the levorotation of fructose is more than the dextrorotation of glucose in magnitude, right? So what happens? The overall mixture, it is levorotatory. That means when you hydrolyze sucrose, so as the mixture moves from reactant to product, there is a change in the optical rotation, sign of the optical rotation. So that is why we call it invert sugar. So yes, that is correct. The glycosidic linkage is present between C1 of alpha glucose and C1 of beta fructose. This is correct. Always remember guys, if the carbohydrate is an aldose, right, it is an aldehyde, then it will generally bind with C1, right, okay. But if it is fructose does not have a carbonyl group at carbon 1, it has that at 2, right, okay. And here the structure is, let me just show you, right, yeah. So now you can see that this is C1, but definitely this is not C1, right, this is C2 of fructose, right. So that is why sucrose is a non-reducing sugar. A non-reducing sugar is the one in which the carbonyl groups of the monosaccharide units are involved in glycosidic bond formation. That is why they are not free, and that is why it cannot reduce Fellings and Tollens reagent, okay. So in sucrose, it's a non-reducing sugar, that makes option C as the correct, right. So 1 and 2, the linkages between C1 of glucose and C2 of fructose. So both carbonyl groups are busy, right. So not true is will be the correct answer. So named as invert sugar, yes. The glycosidic linkage is present between C1 of alpha and C1 fructose, no. So that makes option B as the correct answer. Otherwise option C is correct. It's a non-reducing sugar. On hydrolysis it produces glucose and fructose. Yes, any compound on hydrolysis produces its constituent units, right. So this is the correct answer in this case. What about this? Out of the following, which type of interaction is responsible for the stabilization of alpha helix, right. So do you guys know the structure of protein? Please study this from NCERT book, that will be sufficient, right. What is the meaning of primary, secondary, tertiary, quaternary structure, and what forces stabilize these structures? That will be sufficient, right. And lastly, what is denaturation of proteins? So please remember that the sequence of amino acid, you guys know that proteins are polypeptides, right. In every protein there is at least one chain which consists of amino acids joined together by peptide bonds, right. Peptide bonds is this bond, right. Peptide bond is this bond. So the sequence of amino acids in the chain of a protein, that is called primary structure. Now you have the chain, now that chain will fold, right. That chain will fold either in the form of a helix, right, that is called alpha helix, or beta plated structure. Now please remember, these structures are stabilized by hydrogen bonding, right. The carbonyl group of 1, right, somewhere, right, and like this, right, this is an approximation. So carbonyl group of one amino acid and the hydrogen of the NH group, right, of some other amino acid, they are involved in hydrogen bonding, which stabilizes this structure. So the correct answer would be hydrogen bonding, okay. Then you know that the overall folding is called tertiary structure, and quaternary structure comes into picture if a protein has more than one polypeptide chain. Now this is also something you should memorize. There is a list, you know, in the NCERT book. So there are some vitamins have different names. For example, vitamin C is also called ascorbic acid, then there is riboflavin, like that, okay. So please remember the names of some vitamins, their common names, what are their sources, and what are the diseases caused by their deficiency in human body, right. So which of the following vitamins is helpful in delaying the blood clotting? That is obviously vitamin K, okay. Please remember this. Then again, in the disaccharide, please remember the nature of glycosidic linkage, because this is something JEE has been asking repetitively again, right. So what are the types of glycosidic linkages are present in sucrose, lactose and maltose? So sucrose we have just seen, right, sucrose we have just seen. In sucrose, the C1 carbon of alpha D glucose and C2 carbon of beta D fructose, right. So this must be the correct answer for sucrose, right. A matches with second, alpha D glucose and beta D fructose. So A matches with second, right. See, such a simple question. Now lactose is formed by the galactose unit and one glucose unit. So obviously when you hydrolyze lactose, you will get one molecule of galactose and one molecule of glucose. Maltose, it is formed by the combination of 2 units of alpha D glucose. So please remember the nature of these glycosidic linkages in different disaccharides, right. I think these 3 are just the disaccharides you should know: sucrose, lactose, maltose, and then there is starch, there is cellulose. So please remember the nature, the structure of these polysaccharides. Now this, the tests is something you should remember. What are the tests for carbohydrates? What are the tests for protein? Some of this we do in chemistry lab also. So Sullivanov test and xanthoprotein test are used for the identification of. So for this, you would be glad I have brought you this, right, in the tabular form. So these are the tests for carbohydrate. Please read them. First test is Molish test. All carbohydrates having 5 or more carbon atoms give this test. What is the reagent in here? Alpha naphthalene ethanol, and then we add concentrated sulfuric acid. There is a purple ring at the interface of two layers, like you can see here. If you see that, it confirms the compound is a carbohydrate. Then there is Sullivanov test. Mainly it is given by ketosis. Aldoses react slowly. The reagent is resorcinol, right, 1,3-dihydroxybenzene, right, and concentrated sulfuric acid. Ketoses give red color, bright red like this. Aldoses give faint pink color. So typically we do not use it for aldoses. Then there is Barfoot test, which is used to test the presence of monosaccharides. Here we use copper 2nd acetate in acetic acid. And then we have brick red precipitate because of the formation of Cu2O, and that is how, not very clear, but yes, that is how the precipitate looks. Okay, so you got it from here. Sullivanov test जो है किसके लिए यूज होता है? कीटोसिस के लिए, राइट? तो वो तो हमारा कीटोसिस के लिए आ गया. अब अगला देखते हैं प्रोटीन्स के लिए कौन कौन से टेस्ट होते हैं. ये भी देखो, इसको अच्छे से देखो गाइज. दिस इज समथिंग यू शुड रिमेंबर, वेरी वेरी इंपॉर्टेंट. Alright, so biuret test, basically it is used to test the presence of peptide bonds, and obviously every protein will have peptide bonds, right? So the reagent is simple, aqueous NaOH or KOH, and then aqueous copper sulfate. You get a purple solution like this, right? Xanthoprotein, it's used to just test for the presence of proteins. Concentrated nitric acid, color changes from yellow to orange, right? So if you ever worked with nitric acid in laboratory, right, and if by accident nitric acid, dilute not concentrated, dilute nitric acid comes in contact with the skin, then you must have seen that your fingers or palm turns yellow, right? They are yellow spots. So those yellow spots confirm that there is protein in your skin. Ninhydrin test, it's amino acids except proline. Ninhydrin is this, right? The color is deep blue to purple. It almost looks black here, but it is very deep blue, right? So that is ninhydrin test for proteins. So now we have seen xanthoprotein is for proteins. Now we can go. Sullivanov is for ketosis and xanthoprotein is for proteins, right? So not the other way around, not for aldoses and not for that. Okay, so that is the correct answer. Now moving to the next question. Which of the following statements is not true for glucose? So please remember the structure determination of glucose, right? In NCERT book there are 5-6 reactions which help us deduce the structure of glucose, and then there are some reactions which are not shown by glucose, right? That helped scientists deduce that glucose does not exist in the open chain structure. It mostly exists in the cyclic form, hemiacetal form, right? So glucose exists in two crystalline forms, alpha and beta. Yes, the hemiacetal forms. So this is correct. Glucose gives Schiff's test for aldehydes. Please remember that glucose, despite having aldehyde, it does not form bisulfite addition product with sodium bisulfite, and it does not give Schiff's test, right? So this is not true. Glucose reacts with hydroxylamine to form enzyme. Yes, it absolutely does. The penta-acetate of glucose does not react with hydroxylamine to give oxime. Yes, that is also correct. So this statement is incorrect and hence our correct answer, right? Glucose does not give Schiff's test. Please remember, Schiff's test is a test for aldehydes. So what do we do? There is a dye, again a colored compound, rosanilene hydrochloride, the salt, right? Rosanilene hydrochloride. So when you pass sulfur dioxide, the dye is bleached. It loses pink color, right? When you react that bleached rosanilene hydrochloride dye with an aldehyde, the pink color or magenta color is restored, right? That confirms that the compound is an aldehyde. So glucose does not give Schiff's test. That is a correct answer. Again, a very important reaction. You study this in surface chemistry also and biomolecules also, because enzymes are biomolecules, right? There are thousands of biomolecules, thousands of enzymes working in our body, right? So what do you think is the correct answer? Sucrose, when it is hydrolyzed to glucose and fructose, the enzyme is invertase, and when this monosaccharide unit further undergoes breakdown to give you ethanol and carbon dioxide, that is zymase. So very popular reaction, it has been asked in JEE, okay, invertase and zymase. So these are the enzymes. So now a little tip, please go to surface chemistry in NCERT book. There are around 7-8 examples of enzyme catalyzed reactions. Please remember in each case what is the reactant, what is the product, what is the enzyme that catalyzes that reaction, and what is the source of that enzyme. So this is something important. Here we now have come to polymers. In polymers, very simple, remember all the polymers names. What are their types? Are they condensation? Are they addition polymers? Are they biodegradable, non-biodegradable, like that? And what is a monomer, right? What is the molecule required to make those polymers? For example, caprolactam. So we know that caprolactam is actually nylon 6, right? Caprolactam is actually nylon 6. So A matches with third. Have we got the answer? Yes. 2-chloro-1,3-butadiene. So this is, guys, is chloroprene, which is the monomer of synthetic rubber, right? So this, right? And if you take methyl instead of chlorine, that gives you isoprene, which is a monomer of natural rubber, right? Right. So CH2 double bond CCl, CH double bond CH2, CH2 double bond CCH3. Yes, so this is 2-chlorobutadiene and this is 2-methylbutadiene. So this is the monomer of, neoprene. So this matches with fourth, B matches with fourth. Yes, B matches with fourth. Isoprene is that makes up natural rubber, right? This is isoprene. So we also call natural rubber polyisoprene, right? And acrylonitrile is one of the monomers in Bunaen, right? Which is a copolymer of butadiene and acrylonitrile. So acrylonitrile is this, right? Acrylonitrile is this, CH2 double bond CHCN. So that is a component of Bunaen. So that is the correct answer. So please remember the monomers, names and structures of all polymers in this chapter. Again, condensation polymers are commercially very important, right? For example, nylons, polyesters, polyamides, like that. So nylons are basically polyamides. Which of the following is not obtained by condensation polymer? So nylon 6,6 is a condensation polymer, right? Because it is formed by the condensation of adipic acid, which I am writing right now, है ना? ये adipic acid की condensation से बनता है, और hexamethylene diamine, right? COHNH2, COHNH2. Is that clear? Okay. Nylon 6,6 condensation है. Bunaen is an addition polymer, right? So Bunaen में क्या होता है, guys? We take here acrylonitrile. So यहाँ पे हम लोग acrylonitrile लेते हैं. So Buna is butadiene, right? That is butadiene and acrylonitrile. तो you can see addition polymer होगा यहाँ पे, है ना? Unsaturation है, यहाँ पे addition polymer होगा. So basically that is Bunaen. So this is not a condensation, that's an addition polymer. Bakelite, you guys know, it is formed by the condensation between phenol and formaldehyde. तो ये तो है condensation polymer. And nylon 6, of course, condensation polymer, right? So that Bunaen is the correct answer. It is not a condensation polymer. Then next this. So this question I selected because JEE asks what do they give you, a structure of polymer, and they ask you to figure out what will be the monomers or vice versa, right? So you can see that this is urea, right? It must have lost one hydrogen here, right? And it must have lost one hydrogen here. So if it has lost hydrogen, it must have lost OH, something like that, right? So it seems like that it's a polymer of urea and formaldehyde. So yes, indeed, this polymer is a urea formaldehyde resin, right? So this is urea NH2CONH2 and that is formaldehyde resin. So which of the following compounds is a constituent of the following polymer? This is formaldehyde. Okay, so that is a correct answer in this case. Next, ये तो बहुत ही पॉपुलर है गाइस. प्लीज रिमेंबर जो हमारे बायोडिग्रेडेबल पॉलीमर्स हैं जैसे नाइलॉन टू नाइलॉन 6, राइट? नाइलॉन टू नाइलॉन 6, तो प्लीज इन सब की स्ट्रक्चर याद रखना. दूसरा PHP भी हो गया, विच इज अ टाइप ऑफ एस्टर, राइट? पॉलीएस्टर. सो यू कैन सी यहीं पे देख सकते हो बीटा हाइड्रोक्सी ब्यूटराइट. ठीक है, इतना सिंपल क्वेश्चन है. ब्यूटराइट मतलब 4 कार्बन होंगे, ठीक है, और ये एसिड है तो ये अल्फा पोजीशन होगी, ये बीटा पोजीशन होगी, तो यहाँ पे OH हो गया. right? And beta hydroxyvalerate. So please remember butyrate 4 carbon, valeric is 5 carbon. So this is 5 carbon और ये कार्बोक्सिलिक ये अल्फा हो गया और ये बीटा हो गया, तो इस पे OH ग्रुप अटैच हो गया, ठीक है। अब देख लो यहाँ पे कौन सा कंपाउंड है, तो ये हो जाएगा 1 2 3, दिस विल बी 3 हाइड्रोक्सी ब्यूटेनोइक एसिड, right? And this will be 1 2 3 hydroxypentanoic acid. So of course this is the correct answer, 3 hydroxybutanoic acid, 3 hydroxypentanoic acid. So please remember PHBV is a biodegradable polyester, right? In this question, so this question I picked because JEE Main, they are very clever, they just pick the lines of NCERT book and there they ask question from, right? And in fact this is what has been happening in the last few years in JEE Advanced also, right? They take some concept from NCERT books directly and make a question on the basis, right? So high density polythene HDPE, high density polythene HDPE. So which do you think matches here? So yes, Ziegler-Natta catalyst, that is the catalyst we use, right? Triethyl aluminum and TiCl4. So please go through this. It's a very important polymer, straight chain polymer, very closely packed. Okay, high density polythene matches with third, Ziegler-Natta catalyst A matches with third. So either this option A or D. Polyacrylonitrile. So we just discussed acrylonitrile is CH2 double bond CHCN. So this is acrylonitrile, guys. So now it undergoes addition polymerization. So of course यहाँ पे हमें क्या चाहिए, यहाँ पे क्या चाहिए हमको peroxide catalyst चाहिए, ठीक है। एडिशन पॉलीमराइजेशन में peroxide catalyst चाहिए होता है, प्लीज याद रखना, ठीक है। तो बी आई थिंक फर्स्ट के साथ मैच करेगा, वो दोनों में मैच कर रहे हैं। सी देख लेते हैं, नोवोलैक। सो व्हाट इज नोवोलैक? इट इज, यू सी, व्हेन फिनॉल रिएक्ट्स विद फॉर्मल्डिहाइड, फिनॉल रिएक्ट्स विद फॉर्मल्डिहाइड तो पहले लीनियर पॉलीमर बनता है, लीनियर पॉलीमरिक चेन बनती है जिसको हम नोवोलैक बोलते हैं, राइट। और एसिडिक या अल्कलाइन मीडियम में दिस नोवोलैक जो है which is it is used in paints and lacquers, right? Remember that. Now it undergoes condensation, it forms bakelite, ठीक है। तो नोवोलैक जो है वो मैच करेगा फोर्थ के साथ, तो ऑप्शन ये वाला होगा। एक बार डी भी कंफर्म कर लेते हैं, डज डी मैच विद सेकंड? नाइलॉन 6 is condensation at high temperature and pressure. Yes, it's a condensation polymer, nylon 6, right? So yes, option A is the correct answer. तो ये सब याद रखना गाइस, ये काफी इंपॉर्टेंट है। Again, which of the following is classified as a condensation polymer? Dacron, Terylene, heard of it? So this is ethylene glycol, right? It's a polymer of ethylene glycol and terephthalic acid, right? You can see it's a polyester, right? यहाँ से हमारा H जाएगा, यहाँ से OH जाएगा और similarly यहाँ से H जाएगा, तो it looks something like this: OCH2, CH2, O C double bond O, and then benzene ring, and then C double bond O, like this. Okay, so Dacron, Terylene, that is a condensation polymer, that is the correct answer. Let us look at other also. Neoprene, synthetic rubber, अभी हमने डिस्कस किया था, it's a polymer of 2-chlorobutadiene, right? Yeah. So Teflon, PTFE, ठीक है। Teflon you guys know, tetrafluoroethene, इसका हमारा पॉलीमर होता है CF2 double bond CF2, right? पॉलीटेट्राफ्लोरोइथीन। सो ये तो एडिशन पॉलीमर है, ये भी एडिशन पॉलीमर था। पॉलीएक्रिलोनाइट्राइल पैन, वो भी हमने डिस्कस किया, एडिशन पॉलीमर है। तो डेक्रॉन हमारा एक इंपॉर्टेंट कंडेंसेशन पॉलीमर हो गया, राइट। ये बताओ इसमें अट्रैक्टिव फोर्सेस का क्या है? अट्रैक्टिव फोर्सेस समथिंग अगेन जो जेई में पूछा जाता है डिफरेंट पॉलीमर्स में, वो आप लोग पता लगा सकते हो, ठीक है। जस्ट लुक एट द स्ट्रक्चर ऑफ द मॉलिक्यूल, इज इट लाइक ऑलमोस्ट नॉन पोलर हाइड्रोकार्बन्स, और डज इट हैव पोलर बॉन्ड्स, और इट हैज CONH bonds, hydrogen bonding. So among cellulose, polyvinyl chloride, nylon and natural rubber, the polymer in which the intermolecular forces are weak. So please remember, nylon, they have hydrogen bonding, right? Because they are polyamides, they have hydrogen bonding. Cellulose has hydrogen bonding, it has OH groups, it has hydrogen bonding, and in polymers, hydrogen bonding would be considered as a strong force, right? Polyvinyl chloride, it has CCl bond, so it has polar covalent bonds, so not as strong attractive forces as nylon and cellulose, but still they are polar covalent bond. But natural rubber is almost, you know, non-polar. You see, this is the monomer of natural rubber, isoprene, ठीक है। isoprene. So CH2 double bond C, CH3, then CH double bond CH2. So this is almost non-polar, so that is why natural rubber has the weakest intermolecular forces. So correct answer कौन सा हो जाएगा? Option 4. अगले क्वेश्चन पे चलते हैं. तो हर एक टॉपिक से मैंने एक क्वेश्चन उठाया सो दैट यू आई एम एबल टू गिव यू एन आइडिया कि ये चैप्टर कैसे प्रिपेयर करना है. सो प्लीज रिमेंबर जो डिटर्जेंट्स है हमारे कटाइनिक, अनाइनिक, न्यूट्रल स्ट्रक्चर्स जो एनसीईआरटी बुक में दे रखी है एंड व्हाट पर्पस दे आर यूज्ड फॉर. ठीक है, वो चीज़ याद करना है. तो लॉरल सल्फेट नाम से पता चल रहा है ये अनाइनिक डिटर्जेंट होगा. ठीक है, ये हमारा करेक्ट आंसर हो गया. सिटाइल ट्राइमिथाइल अमोनियम ब्रोमाइड ये कटाइनिक डिटर्जेंट है, ये हमारा हेयर कंडीशनर्स वगैरह में यूज होता है. इट इज गिवन, प्लीज रिमेंबर द नेम, the structure and what purpose it is used for, right? Glyceryl oleate, it's fat, right? You see oleic acid ka glyceryl ester, so it's a fat. Sodium stearate, it's a soap, it's not a detergent, right? Soaps are salts of fatty acids. Okay, this is not a detergent, it's a soap. So the correct answer is sodium lauryl sulfate. ये देखो, ये काफ़ी जानी मानी स्ट्रक्चर है, ये हमारी बनती भी है, हम लोग पढ़ते हैं इसको. क्या नाम है इसका? Is it an insecticide, antihistamine, analgesic और antacid? So अगर आप लोग ध्यान से देखोगे तो ये है 2-एसीटॉक्सी. ठीक है, इसका IUPAC नेम मैं बता रहा हूँ. So this is 2-एसीटॉक्सी benzoic acid, right? 2-एसीटॉक्सी benzoic acid, और in common system you can call it acetyl salicylic acid. याद आया, right? Acetyl salicylic acid, acetyl, and this is salicylic acid, right? OH. So guys, this is aspirin, for which you must have heard the brand name Disprin, right? Brand name Disprin. So it acts as an analgesic and also it has blood thinning property. It is also used in heart attack, right? So basically here it matches with analgesic. Analgesics are painkillers, right? So that is the correct answer here. अगले पे चलते हैं. ये आप लोगों को याद रखना है, एंटीबायोटिक. यू गाइज नो दैट एंटीबायोटिक्स सेव मिलियंस ऑफ लाइव्स एवरी ईयर. एंटी फर्टिलिटी ड्रग्स, दे आर important because the world's population is literally explosive, right? And hypertension, with modern lifestyle these problems are aggravating. So what do you think? What do they match with? So please remember, in this chemistry and everyday life chapter, all the drugs like analgesics, antihistamines, okay, tranquilizers, antibiotic, fertility drugs, like that, okay, antiseptic, disinfectant, and their examples. Make a table in your rough notebook. Remember the examples because in JEE Main they are asked. So norethindrone, it's an anti-fertility drug, right? It actually prevents the complete development of egg, right? And therefore it prevents fertilization, right, of the egg by the sperm. So norethindrone is an anti-fertility drug, so A matches with Q. So either of these. Then ofloxacin, you must have heard these names, ofloxacin, cloxacillin, ampicillin, like that. Okay, so these are antibiotics, right? These are antibiotics. So B matches with P. I think that gives us the correct answer. So C must match with R. Yes, Equanil is a drug for hypertension. Okay, so these names is something you have to remember. What is the drug used for, and you know, and first what is the meaning of these terms, right? What is hypertension, okay, analgesic, what is the meaning of antipyretic? So this is something you should remember in chemistry in everyday life. Artificial sweeteners is something you should remember, right? Because everybody enjoys, you know, sweet food, desserts, but not all can eat it without, you know, guilty. So artificial sweeteners is something which comes to your rescue. So artificial sweeteners, they do not add calorie, right? They do not add literally sucrose to the food calorie intake. So even diabetics can use it. But then again, with everything comes a problem. So which of the following artificial sweeteners has the highest sweetness value? Okay. So allitame is the one whose sweetness factor is 2000 times. That is, it is 2000 times more sweet than sugar. So of course the control of sweetness in the food will become difficult, right? So allitame is the correct answer in this question. So please remember what are the different artificial sweeteners. If possible, remember their structure also, right? Because JEE has also asked the structures of these artificial sweetening agents, and then of course what is the sweetness factor, right? And then if there is any special point about it, like I told that allitame, the control of sweetness is difficult. Then this question Broad spectrum, narrow spectrum antibiotic, this is something you should remember, right? Antibiotics can be classified into many categories like gram positive, they are effective against gram positive and gram negative bacteria, or they are broad spectrum, narrow spectrum, like that, okay? Bacteriostatic, bactericidal, all of this information you will find in NCERT book. So which of the following is not a broad spectrum? Very simple logic: penicillin. Penicillin, a narrow spectrum antibiotic. Please remember vancomycin, ampicillin, ofloxacin, these are broad spectrum, but penicillin G is a narrow spectrum antibiotic. So that is the correct answer in this question. So that's all in this video. I hope you guys learned a lot of, were able to revise a lot of important concepts with the help of these questions. Tomorrow I'll be back again with some chapters of inorganic chemistry, okay? तो प्लीज़ इस YouTube चैनल को सब्सक्राइब कर लो, ठीक है? वरना मैं यहाँ आऊँगा, वीडियो मैं इतनी सारी चीज़ें मेहनत करके एक्सप्लेन करूँगा एंड यू गाइज विल नॉट बी देयर टू बेनिफिट, राइट, विद दिस अमेजिंग कंटेंट. सो वापस आएंगे कल इसी वक्त, मिलते हैं इनऑर्गेनिक केमिस्ट्री के चैप्टर्स के साथ. टिल देन टेक केयर, बाय बाय.